here we have two functions, well, one function and a constraint. You're asked to find the critical points of the function f of x, y, z, given the constraints g of x, y, z. So our function is x squared plus 2y squared plus z, and our constraint is x squared minus z squared minus 2. Now, I'm going to ask you to work this out, and I worked it out already. The answers I get for the locations were 3 over 2, 0, negative half, and negative 3 over 2, 0, negative half. Right? Those are the answers that I got. I'm going to ask you to work it out, and, well, if I didn't make any mistake, then you would get these answers. Now, just as a reminder, remember now, the formula is that the gradient function, the gradient vector of the function is this Lagrange multiplier times the gradient vector of the scalar. The function, the gradient vector of the function would be partial derivative of the function with respect to x in the I direction plus partial derivative of the function with respect to y in the j direction plus partial derivative of the function with respect to z in the k direction is equal to lambda times partial derivative of the function of the grade of the constraint with respect to x in the I direction plus partial derivative of the constraint function with respect to y in the j direction plus partial derivative of a constraint function g in the z direction with respect with respect to z in the k direction, right? Well, if you open the bracket and multiply them, you get lambda this equal lambda that and lambda the other. Alright. And you equate the coefficients. Right? You equate the coefficients. You have delta f by delta x would be equal to lambda delta g by delta x. And then delta f by delta y is equal to lambda delta g by delta y, and delta f by delta z is equal to lambda delta g by delta z. And then you have the constraint itself, g of x, y, z. So you solve those will be 4 equations. You solve them to obtain the locations x, y, and z. Alright, so work it out, and let's work it out together in the next video.